Okay, in this video we will continue on the beginner's guide to SDL2 and COBOL. If you're just joining this video, you will need to go to GitHub Programming Rainbow, Beginner's Guide to SDL2 and COBOL, and you'll need to clone that repository. We will be working from the source code from video number 2, so you're going to need to copy the source file from video number 2 right here. Well, it'll be on your local computer when you clone it. But you'll need to copy that source file from there into the source directory, and that's where we'll be working today. So this is video 3. We will be working again from the source code that we ended off with in video 2. Okay, so in video 2, we were able to create a window, but we don't close it. It closes itself, and it doesn't listen to any of our input. It doesn't accept our close command or anything like that. It just opens up and it closes. So this video will be all about getting user input. It'll be for the SDL events. The events that happen, we're going to be capturing those events and dealing with those events. We're going to need to talk about SDL events. So we have a function called pull event, and it pulls and it populates something called an SDL event. So what is this SDL event? Well, it's a union. This is in C. This is not a COBOL thing. This is in C. This is an SDL union. And a union is, if you're not familiar with unions, it's imagine you have a box, a shoe box. Your shoe box can hold one pair of shoes. Okay? You might have 50 pairs of shoes, but if you have that shoe box that you're holding, only one pair of shoes can be in them at a time. But you could take those shoes out and you could put different shoes in. So maybe if you were letting a friend borrow a pair, or maybe if you were sending a pair off to have it worked on or changed, repaired or having it bedazzled or something, you might put a pair of shoes in that shoebox. So that shoebox is like a union. It can handle one pair of shoe, but you could put all 50 different ones in, but you can only put one in at a time. So imagine we have structs that have many different members of them. So structs is like many different boxes. But a union is just one box. It can hold all of the different types, it doesn't have to be a specific one, but it can only hold one at a time. And the size of it needs to be the size of the biggest one. So again, if you're thinking about shoes, your shoe box to hold all of your shoes that you own needs to be at least as big as your biggest pair of shoes. Okay, it's got to be able to hold your biggest shoe. Your smallest shoe may fit in it with some extra room, but it needs to be at least big enough to hold your biggest shoe. And then that's a union. So you can put one item in it, and it doesn't matter which one. So that's a union. So what an event is a union that holds structs. So basically, that union has to be big enough to hold the biggest struct it could be, but we don't know what struct is going to be in it. So it has a type, and then it has struct. So that type basically tells us what type of struct is being held inside of it. So it's just like if your shoes, if you had a label that you also put in your box, that fit in your box with your shoes, and the label said it's running shoes. And then when you put different dress shoes in, you put a label said this is dress shoes. So, or maybe you put it on the outside so people would know what it is. So that's a union. A union can hold lots of different things, but what for this union, for this event union, it's got a thing that is a type that's in all the unions that are specified. It's in no matter what's in the union, there's always going to be a type. And that type is just telling you what's the struct that's inside of it. And there can be many different structs, but we actually only care about one struct. There's two things that we care about in this whole event union. The first thing is it a closed type? So on this union of the types that you can have, just this top level thing, before all these things down here, those are all structs, but this top level thing is just a type. And each one of these structs has a type in it. So they all have one thing that matches up. It's the type. So no matter what kind of struct is sitting inside of your union, you can always call the member for the type, and it's defined in all of them. So you can always find out what type of the thing is you're holding, because you need to know the type of it to know how the memory's laid out and how to work with that thing. So I know this might be a bit weird. You might have to read about unions and structs if you don't already know about this, but one thing we want to know about is, did a quit happen? Quit event happen? And that's going to be of type quit. So if we, is it down here further? Yeah. So if we look at the SDL event field, these are the different structures it could be, but these are the different types of structures, and these are the actual structures, and these are the kind of enums that we would get. So when we're checking the type, we would get an enum if it was a quit type. Where is quit? We would get SDL quit all capitalized. It would be an enum that is SDL quit, and that would tell us, hey, that this struct that we're looking at that's sitting inside of this union, it's a quit type. We don't need to know what's inside of that struct actually at all. We just know that somebody has asked this program to quit, and we're going to listen to that. So that's one thing that we want to know. The other thing is going to be buried inside of a struct, unfortunately. So this one, we don't even need to worry about the struct at all just to get that union thing. We can just look at the type of it, and if it's a quit type, we know that we're shutting down. But the other type that we're interested in is this, if the type returns as key down, it's going to be this keyboard struct. Let's see, the keyboard event. And it's going to look like this, but it's actually a bit bigger than this in memory, but this is just in the documentation. And what we want to know is whether, like, say, the escape key was pressed. I mean, we'll be using other keys later on, but not right now. I'd like the window to close if I ask it to close, and also if I press the escape key. So we're interested on this keyboard press event. So if the event did happen that is a keyboard event, we need to know what key was pressed. And this drills all the way down. This gets a little complicated. We'll see it as it goes. But when we get into this key sim here, let's just open it up. So we get in this key sim, it's got more members inside of it. One of them is the scan code. And the scan code are these guys. Okay, and then you can have scan codes for all kinds of things, but the one that we're interested in is SDL scan code escape. Yeah, it's in here somewhere, but it just says escape. It's like any of these. Okay, but if you look all the way at the bottom of this page, all these scan codes are listed, but they're not telling us what order they're in. So how do we know in COBOL how to find out if that scan code? Well, if we look down here towards the bottom, do I have it opened up? No, that's wrong. So there is a scan code lookup table, and this is good for us because we're in COBOL. We need to know the number. See, this is just an enum, is what this is. And this enum represents a number. So we can say, hey, we can map this to a number. And we're looking for escape. So here's escape right here. Escape is 41. Now we know we could either set this in our COBOL, the escape, to 41, and we can just use this now since we've declared it in COBOL, or we can just look for the number 41. So just keep that in mind. The other one we had to look inside the header file to get that number and then decode it into a decimal number. Not this one. This one we can actually just get it out of the scan code lookup table. Okay, but the complicated bit is this whole union struct bit. That's the bit that we're going to have probably half of this video on, making this thing happen. But once it's set up, we'll be able to add other key presses very easily. But the first time it's going to look a bit funny. Okay, so yeah, so what we need to do is basically implement in COBOL this union, but with just one struct version of it, the version that has the keyboard event. Okay, so let's get over here back into our code, and we'll start walking through this thing. So this is going to be kind of a multi-level thing, like the error codes were, but it's going to be a little bit deeper. So we're going to say O1, and this is going to be SDL event. And then inside of that is our union. And what we're going to do for this is we're going to get the type, but then we're just going to give it an overall size. What is the size that this thing must be? And it's actually, if you look through I've had to look through the header files for SDL for the fourth language and for COBOL. So I already know from dealing with the fourth language what size this C, the size the union is in C, and it's actually 52. It's one int plus 52. Yeah, so it's 56, I think, not size totally. But anyway, we need the int and then another 52 of just space, just so we can say, hey, our container is this big. And that will be the largest, like the largest shoe size you could put in the shoe box. We need a box that's big enough for this. So it's 05. This is going to be SDL event default. Now this is like the label. SDL events the label for COBOL, and I don't know what the COBOL name for it is, but that's the way I think of it. And the thing inside is actually the 05 level is actually like the struct or the union that I'm making. So SDL event default. Now this is my default size. Like I said, this is just a generic one that's just going to hold a type and it's just going to make it the size that it needs to be. And we do something like this in fourth as well. So now inside of this, we have SDL event, and this is the type. This is the one that's going to tell us what type of event it is. And we'll do usage, binary int, unsigned. I guess we could have said unsigned int. Doesn't matter. So that's the type thing. This is the one that we're very interested in. This is going to tell us, is it a quit event or is it a keyboard press event? So that's going to be our top level thing that we look at. And then the thing next is, well, first for this one, just to make it exist, we're going to put padding in it. We're going to fill it up. So we'll do 10, I'll say filler, usage, and I'll say binary char because this is going to be 1 byte. Binary char is 1 byte. I don't really care if it's a character or not. I just wanted a byte in size. So I can just say how many bytes I want it. And I'm going to say 52 times. So this is gonna this container now is going to be the size of an unsigned int, which is going to be 4 bytes, and then it's going to be the size of 52 more bytes. So it's going to be 56 bytes, and that's the size of the container that you need for the SDL union, or the event union. So, and like I said, many things could be inside of this union. They're all different structs that could be in here, but the only one we care about is the keyboard event. So I'm going to define now the keyboard event. It's going to be a little bit weird unless you are really comfortable in COBOL. But so I'm going to say keyboard event, and I'm going to say it redefines, because this is going to take up the same memory space as what this container we just created up here. What I'm mapping out here is actually going to be mapped on top of it. So it's going to say redefines. SDL event default. Okay, so this thing that I'm doing down here is going to redefine this. So we know now that it's 56 bytes, and it's got a type, got an event type. So this is going to be keyboard event type. So basically, I'm recreating what the actual implementation of the SDL struct for the keyboard event is. So this is going to have padding and everything. This is so it lines up in memory. Now, if you're on I can't guarantee this thing works on anything other than like a 64-bit system. I think the padding lines up the exact same for SDL and the 32-bit system, but I'm not exactly sure. So we're going to see keyboard event type, usage, binary int, and again we're saying unsigned. So we're going to see keyboard timestamp. Like I said, if you look up the header file for this, I should have pulled up the header file. This is how it's defined in the header file, with these paddings and all kinds of stuff. Well, the padding sometimes it's defined in the header file and sometimes it's not. But see, the compiler adds the padding in too. So sometimes they define it too, so they know exactly where the padding is with these kind of C structs. Because it's for alignment of how, like, if you have an 8-byte pointer and then you have a 1-byte char and then you have something that's 2 bytes, it doesn't work that way. It needs to line itself up in like an 8-byte boundary. So the usage, and it's the same binary unsigned. Don't want it to wrap. Oops. What's this procedure? I must have pressed something wrong. Why are we doing this? Okay, well, I guess some of these are going to wrap around. A bit ugly. So 10 event window ID. ID binary int unsigned. Keyboard event. And then this one is the state. So these three are int. This is a binary char unsigned. Repeat. Usage binary char unsigned. Keyboard. Okay. It's a bit concerning. It says padding 2. I don't know what happened. Maybe that's the way it was written in the struct for SDL. Sometimes that happens. They got mistakes in there. Binary char unsigned. Yeah, I think some of these are going to wrap. Okay, this will be padding 3. So, and then we have two binary ints, the scan code and the sim. It's good that we only have to do this for keyboard. Keyboard, scan code. This one's just binary int, yeah. Binary int. And then sim is also binary int. Usage, binary int. Now we have a binary short unsigned. So this is mod. We have binary short unsigned. And is this the last one? This is event unused, which is basically padding again. Binary int unsigned. Okay, that is the entire thing. I just want to go through and really make sure that I didn't write any of them incorrectly. So this is a binary int unsigned, yes. Okay, and then this is filler, binary char, 52 times. And then redefines SDL event default, yep. And we got usage, we got binary unsigned int, binary unsigned. I have that 3 times. 1, 2, 3. And then we have binary char 1, 2, 3, 4 times. And then we have a binary int. Two binary ints, and then an unsigned short and an unsigned int. Okay, well, hopefully that's correct. I guess we'll find out in a little bit. So now that we have this set up, we can actually make use of it by checking for events. So we're going to make a procedure named check input, and it's going to be above the draw all. It doesn't really matter where it's at, but I'm just putting it here. So we'll have this check input. And what this is going to do, this is going to perform with test after until return. Okay. So we're basically going to perform something over and over again until our return value equals 0. That meaning there's no more left in the queue. So this SDL pull event, it gets a queue. Basically, every time we run this function, there's a queue of events that happened, and each event is this union that we were talking about. Okay? So if there's 5 events that have happened, when you do this pull event, it's going to fill up your event. It's going to take in the address of your event and fill it up with one of those events. And then you can test it and check it and do all your stuff. And then when you call this function again, it fills it up with the next one until it's empty, and then it's 0. So what we're looking for is we want to run a loop on this until our return from this is going to be 0, or it returns 1 if there is pending event, or 0 if there's none available. Yeah. So when this SDL pull event returns a 0, we don't need a loop anymore. So we're going to create a loop that does that, and it just keeps going through the events and keeps populating our union with one event at a time. So we're going to do perform with test after until return value. That's we are always sticking our generic returns into this return value variable, unless it's a specific thing. Equals 0. So that's our kind of thing, saying we're saying do this thing over and over again until this returns equals 0. And the test is after. Okay, so what's the thing that we want to do? Well, first we want to call that SDL pull event to get a new event. So we're going to say call SDL pull event. And we're going to say using by reference, because we're sending the address of it in, the SDL event that we have. I'm going to put the using up here because I always do that. That's just the style that I just keep doing the same style every time. By reference, SDL event. Okay, and we're not putting a period on this. This whole perform all the way to the end of the perform thing is one sentence. So that's where the period is. It's going to be a long sentence. Okay, and we're returning the return value. So we can check that. Okay, so now we have that's going to be our end call on that. Oh, sorry, that's not a period there because this is inside of this perform sentence. So this call right here is just populating our union, our event union, with whatever it is, and also seeing if the union is something. Because if this returns 0, that means it's done. Well, actually, it's telling us is the next one going to be, but yeah, it's the same thing. So we're going to evaluate this now. This evaluate is kind of like a switch statement. So I'm going to say evaluate. That's not right. We're evaluating the event type, the SDL event type. Okay, so there's no period there either. So the SDL event type, right here, SDL event type, this is the thing that's in all of them. No matter what you get, you always have this SDL event type populated. This is the thing that we can test if it's a close event or a keyboard event. So that's the thing we're testing first. So we get evaluate SDL event type. And like I said, this is kind of like a switch statement. So we can say when SDL quit. Now, I think we need to define this above. We're gonna need to define this SDL quit. This is another one that should be a macro, but we don't have the header files here, so we're gonna define it like here with our other macros. Okay, I put them separate. I put the these are, what would you call it, for flags. I put the flags separate, just organizing things. So here's a macro. This is going to be the SDL quit. We'll say usage It's a binary int. This is an enum as well, I think. Or it could be a pound define. Value 256. Again, you'd have to look in the SDL header files for these. So there's 256. We'll also look for the SDL key down, which is going to be 768. These sound like they're bit. I don't know if it's an enum or a bit. Like bit encoded. So we'll say SDL key down, and this one is the same thing. Usage binary int value, and this one is 768. And then we have the SDL scan code escape. Now the scan code escape is an easier one because that is an enum, and that is actually listed just directly in their documentation on their website. So that one is 41. Just add those in. So now we have those values. So now we can check if the SDL quit occurred, if an SDL key down occurred, and then we can check which key down it was. Okay, so we're back down here into the evaluate, and now we can do this when SDL quit. So imagine this is like a switch statement. It's switching on this SDL event, and it could be, this would be case of SDL, like if you had a switch statement in, say, C or something. Let's get down to there it is. So when we do this, we want to perform an action, and we're just going to perform cleanup and exit, because if an SDL, that's saying something asked this program to quit. So if something asked it to quit, we're going to let it quit. So we're going to perform cleanup and exit. And there's no period here. I keep because this whole thing is one sentence. There can't be, from the beginning of this perform to the end is one sentence. So there's no periods anywhere in here. If you put a period, it won't work right. So we did that when. Now we can do a different one. We can say when SDL key down. And we define that above as well. So what happens when there's a key down? Well, we don't know what key it is. So we need to evaluate the keyboard event scan code. So let's look up here. So we're checking this event type, yeah? And we got the two different types. We got the SDL quit event and the SDL key down event. Now, if we know it's a key down, now we can look in here and we can say, this scan code here, what scan code is that? So we're checking this one now. But we need to know that it was a key down event, because it could be a totally different struct that's in this union. We need to know that it's this one. So we need to check this top level first. And when we know we're looking for a key down event, then we can check what key down it is. And we've already defined the key down. So that's no problem. Where is it? Check inputs. So we have this when key down, and we're going to do another evaluate on it. Whoa, what happened there? It populated a bunch of stuff for me. So we're going to evaluate the keyboard event scan code. The scan code. And we're going to say when SDL scan code escape. So when that key has been pressed, we're going to do the same thing. We're going to perform the clean and exit. Okay, so now that we've finished this evaluation, we're going to close it. So we're going to say end evaluate. It's trying to be smart, but it's just kind of messing me up. Okay, so we ended one evaluate. Now we need to end the other one. Okay, so we have this evaluate. Let's see here. Yep. We have this evaluate. We have the two wins. Then we have this evaluate. We have this win and the end of that evaluate. And then we're going to end the perform. And this period shouldn't be here. And the period goes here in the end of the perform. So this entire thing is one sentence in COBOL. And here's the period at the end of it. So we're performing with test after until return value equals 0. So this is saying if the next event in the queue, I believe, is nothing. If there's no next event, don't keep going with it. And it's evaluating after. So it's evaluating at the end of it, I think. So we have SDL, we're calling the pull event. That's populating our return value and it's populating our event. We're sending the event in as a reference and then this function is populating that. So we have our event. Now we're evaluating the type of the event to see if it's an SDL quit, we're cleaning up, or if it's a key down, now we need to evaluate which key it was. And we're only looking for one key here, which is the SDL scan code escape. We don't care if it's any other key that was pressed, just that one key. And in both cases, we're shutting down the program. And I'll add the exit here. Here. There. So we've made this thing where we're checking all the time, but we don't have a game loop yet. So up here in the main procedure, where is it? Right here. We need to make a game loop here that we can check over and over again. Because now we're dealing with events. We don't want it to just stay open for 5 seconds. So what we're going to do, I'm going to create another variable up here. And I'm just going to call it playing because if I can do this without creating a variable. I can just do the kind of while true, while it's always true, do the thing. But because of the compiling warnings and errors I have set, it will think that that is possibly a bug and it'll complain about it. So I'm going to create a variable here that just is a playing variable that I'll set to true. Playing usage. This is just a binary int, I guess. Binary int value. And we'll set it to 1. So this is just a sentinel, but we are never going to check this because we want the playing loop to just always happen. So we're never in the program going to change the value of this playing. So in my first version, I didn't even have a value there, but when I put the stricter things on there, it did not like it. So we don't want the initialization to happen in a loop. So we're going to leave that, but we're going to make the loop after that initialization. So we're going to say perform until playing equals 0. Yeah. So we're going to perform this loop until playing equals 0. It used to be, I used to have perform until 1 equals 0. And after I put the more strict compiling rules in place, it was like, no, you can't do that. So first we're going to check input. So we're going to perform, not that. Okay. So we're checking inputs, and then we're drawing everything. Then after we draw everything, we need to pause the program. But we don't want to pause it for 5 seconds. We want to pause it for about 16 and 2/3 milliseconds, because that is around 60 frames a second. So if we just pause it for 16, maybe the code itself runs for 0.6, I don't know. So we'll get close enough to 60 frames a second. So we're gonna change this from 5,000 to 16, because we don't want our loop to loop one time and then wait 5 seconds before it checks again and draws again. We want it to draw over and over really fast. So this is going to be 16 now, and then we need to end our perform. And since we are never coming out of this, we don't need this right here. We're never coming out of this loop here, because I'm never going to change this playing state. So we don't need to clean up here, because what the cleanup is happening in the check input or on the initialization if something fails. So this is never going to be cleaned up. And end perform, and that's the period on that. This shouldn't have a period on it because it's inside of this sentence here. So we have our infinite loop right here, and it's checking input, it's drawing everything, it's delaying, and then it's doing it again. And it doesn't care, it's just doing it infinitely. The check input is what is going to check if we need to close down. If a quit has occurred, a quit request has occurred, we're going to close down. If an escape key was pressed, we are going to close down. And also, it closes down on if anything fails when it's initializing. So we're initializing and then running this loop forever. I'm just going to put the exit here. Just for readability. Okay, so there's my main procedure. Maybe I'll just put something there. Just want to look at overall the code before so that's exiting. Okay, now we'll see if I made any spelling errors. Yes, I did. Okay. Pause requested for SDL event. Header missing. Okay, so it really doesn't like what's happening here. Let's go up and look at the syntax around 33 and see what's happening there. All of these have periods on them. Yeah, they do. So SDL event loop, yes, 05 is SDL event default. And then I have SDL, oh, right here. That's right, and this 10 right down here is not right. Oh no, that is right too. Okay. Let's just try that real quick. I think I just missed that 10 there. Okay, a little bit less worse this time. Around 35, we have a same thing, so we still have another problem. Read defines. Error, okay. Larger redefines use. Okay, so these don't fit. So I've messed something up here. Size of keyboard event larger than the size of SDL default. Okay, so we have event is usage is a binary int that is unsigned. Fill usage binary char occurs Before I put occurs in there. Occurs 52 times. Maybe that's the problem. Oh, that was the problem. Okay. So I'm going to press escape and it closed. And then I'm going to do a close request and it closed. Okay. Again, this was a long one because of this whole setting up this. We won't have to change this much later because we will be checking for other keyboard presses, but this is already set up for all keyboard presses. And we aren't checking any other real types of events during this thing. So we're only checking ever keyboard or quit. So this is going to be good now. So what we've added here is we've added this play sentinel here that we just always have on as to 1. That just gives us our infinite loop. We have added a couple of these constants in here, these SDL quit. And you would, like, again, you're going to have to look these up in the header file for what they're defined as in the header files. But it's just 256, 768 for the key down. And this one you can actually find easily because it's on the website. This one you don't have to dig in. You can just go here and it gives you the number right on the side. For the escape, it's right here. It's just an enum and it's actually documented. Whereas the other ones, they're documented in the header file, like when you read the source code. Okay, so we have those set up. We have our playing. And then what we've done here is we've made a vessel that's big enough to hold this keyboard event. So it doesn't have to be the keyboard event, but it's going to be big enough to hold it. So it's going to have an SDL event type. And then if it is a keyboard type, then we can actually grab the scan code. All of this stuff is just to get the scan code out because it's all lined up with the correct size and everything. And we've created an infinite loop in here. And we're doing our check input, our draw, and we've changed this to 16 milliseconds. And the only other big thing is our input here. This is just a loop that's looping through until there's no more events in the queue. And we're grabbing the events, we're populating our SDL event, and we're returning the return value from it for the checking. And then we're evaluating it. And like I said, this looks a lot like a switch statement to me. This is evaluating, and it's when this happens, do this. When this happens, evaluate this, and then when this happens, do this. So it's kind of like it's not really like if to me. It's more like a switch statement, but it's pretty small code for that. I like that. And nothing else has changed. So that's it for this one, and that was how to close an SDL window. Yeah, I hope that's kind of finishes up all the kind of boilerplate and we can actually start doing some fun stuff. But again, thanks for watching. Bye.